one of the great things about Ryerson Engineering is that we have over 50 different teams. I just found out it was 51, but we have over 50 different teams that you can get involved in. So whether it's a specific team or a student group or a program union, there's different ways to get connected with people in your program, but also ways to be connected with people not in your program. So you don't have to be a part of mechanical engineering to be on the Formula Racing team, or you don't have to be specifically electrical engineering to be on the Rams Robotics team. And to kind of show that point, we've actually invited the Rams Robotics team to join us today. They're going to go through and actually show you how they design their different projects. They're going to tell you about different competitions that they go to. I'm going to invite them to reveal themselves, I guess you say at this point. And we'll do a quick introduction of the Rams Robotics team, and then we'll dive into a few demonstrations or kind of show and tells. So take it away, Rams Robotics.
Thanks so much, Jeff. Hi, we're Ryerson Rams Robotics. We're a robotics team at Ryerson, one of the largest student design teams at the school. And like Jeff said, we have people from all different disciplines. If you scan that QR code that you can see on the shared screen right now, that'll take you to our social media. We have a YouTube channel, an Instagram channel, or Instagram account. We do all different kinds of science education. We do classes in coding and in SolidWorks, and also just fun videos of the road. I'm Vanessa.
I'm Gabe.
I'm Trevor.
I'm Reen.
And what are some of the robots we design on our team? Well, we have a Mars rover named Navi. She's pretty awesome. We also have a sub named Felix, and we have a hoop shooting robot for basketball named Ramsbot, and we are designing a robotic goalie. So we're going to play a video for you right now that shows some of our robots in action so you can get a So you got to see some of our robots there. And also you saw some of our sub-teams. On the robotics team, we have 5 different sub-teams. We have mechanical, controls hardware, which is like electrical design, software. We have a science team, and they work on the research to identify life on Mars. And we have a media and outreach team, which we work on science communication. If you have any questions while we're presenting, you can type them in the Q&A, or we're going to answer them at the end. Now I'd like to introduce Gabe, our team captain.
Hi, everybody. As Vanessa just mentioned, my name's Gabe. I'm a fourth-year computer engineer here at Ryerson University. This is going to be my 5th year on the team on R3. I started my journey on the team in first year. I came in September, and I started right away in the team. I helped design our first rover. So you saw our rover there in the video. I helped design the first one years ago, back in 2017, the first time we competed. And here I am now as captain of the team. And throughout my journey, I've worked on a whole variety of projects, almost all of the projects that we've done in my last 5 years. That's actually something I enjoy about being on this team quite a bit, is that you have a lot of opportunity to try out the things that you learn in school and apply things that you don't learn in school to things that you do learn in school. And it's just a lot of opportunity to build practical knowledge and build things that like do things in the real world. On top of that, it's also a really great place for you to learn how to work as part of a team, or how to work as a team leader, leading a team, like a group of students to assess a problem or to compete at a competition, or a lot of different things, produce a video, lots of stuff. So as I mentioned, I've worked on a variety of projects. With me here, if you give me a really quick second. With me here is our autonomous submarine. Now, let's see if the camera will follow me from one to the other. Can you see me down here? Maybe?
Yep, all good.
Okay, so you can see me down here. This is our autonomous submarine. So this is Felix, like Vanessa mentioned, and it's capable of traversing in all 3 axes. So we designed this guy for the RoboNation RoboSub competition, which is held in San Diego at the Transdeck testing facility. There we compete against like 50 other universities and a whole variety of different submarine designs. And we designed Felix to be very robust and very good, not just for one competition task, but for all competition tasks. So we focused heavily on being able to traverse and navigate through the water. Basically, what Felix has to do is there's like a whole obstacle course that's defined at the beginning of the year. And Felix has to navigate its way through the course completely on its own, using things like sensors, cameras, and a whole bunch of stuff located throughout this guy. So we designed Felix to be to have a holonomic thrust configuration. So what that means is it can move forwards, backwards, left, right, up, down, as well as rotate about all these axes. So it can pitch, it can roll, and it can yaw. So that allows us to do a whole bunch of different things. One of our specific competition goals was to get the low-hanging fruit in terms of points and do some style stuff, since we have a very mobile robot. For example, you could do a barrel roll through one of the goals, and that yields a whole bunch of extra points. On top of that, we've designed these little torpedoes, as Felix needs to be able to shoot at goals and targets. It also uses the cameras to identify objects and a whole bunch of things. I specifically worked on the control system for this guy. So I'm a computer engineer, as I mentioned. So I designed things like the boards and wrote some of the low-level software that allows Felix to talk to its thrusters and actually output what it needs to do. Basically, everything it needs for it to actually do the autonomous algorithm that it runs. So now I'm going to come back to my computer here and turn off this one. Awesome. So something that I've been doing recently, as I said, I'm a 4th-year computer engineer, which means I'm in my last year. So it's time for me to do my capstone. Capstone is something you do with your engineering degree, basically to say, like, I have the knowledge required to do a project. Every engineer has to do it. So my capstone has been designing an autonomous car. One of the problems I've been dealing with recently is I needed a platform to test our actual algorithm on. Testing it on my own car is a little bit out of the question. So I bought a brand new car, as you can see here. So something I've had to do recently is design a control system to interface with this guy's already existing hardware. It already has one, but it's not very good, and also it's very close source, which means it's very hard to interface with. So something I can show you here with me. Ooh, I think it's this one. Oh, no. Stop share. Oops, sorry. I believe everybody can see this. So this is the schematic for the control system design. This is a design tool that we use very often. This is called Eagle or Eagle CAD. Basically, we use this tool to design the schematics for the boards that we're going to design. So this is just a very simple little board. This is the actual controller and the communications. These are the actual motor drivers that I've designed. These are just my connectors. And really quickly, I'm going to have to switch from one to the other. And then once you've designed the schematic and you've verified it by doing all the calculations, making sure that you have sufficient power supply, signal integrity, a whole bunch of different stuff, you go ahead and you lay out the board. And then once your board is verified and designed, like you're finished, you're sure with it, you're happy with it, you send it off for manufacturing, which is where my board is right now. And it should be back here in like a few days' time. Ready for me to build it, put it on my capstone, and get to testing. Yeah, so a lot of the practical knowledge I've learned here on R3 and through school, it's really, really important stuff. And I feel that R3 gives you a place to actually try out this knowledge and really to learn how to conceptualize a project, how to build your prototypes, how to design and test the system, and then redesign it once you've broken it eventually, and really learn some of the key concepts of engineering or like test engineering. So I'm going to pass you guys off now to Vanessa. Vanessa is our mechanical and outreach lead. You saw her just a few minutes ago. Over to you, Vanessa.
Hi, I'm Vanessa Van Decker. I am studying mechatronics engineering at Ryerson. I've also worked on cardiac catheter robotics research with Ryerson professors, and I've been on the Ryerson Rams robotics team since first year. So what do I do on the team? Well, like Gabe said, I'm a mechanical lead. Recently, I've been working on redesigning our rover chassis, and we've decided to manufacture that out of white PETG because during COVID, we've had to socially distance and work from home. So that's an agile manufacturing method that we can do remotely. And we had a whole bunch of different people print panels, and then we sent them to each other and manufactured them so we could all stay socially distanced, but still move forward with our designs and improve our rover. So I'm going to show you a little bit of how we do that kind of thing. So recently I've been designing a claw for one of my classes, actually a manufacturing class that I'm taking in my degree. And so I first use SolidWorks to design the part. You can see here, I'm designing a claw. This is the back left claw on my piece, and here it is here. This is the claw all put together with 3 different claws. So this is one of the 3. Then once I've done parts, I have to put them together into an assembly. So I do that, and you can see I've done a whole bunch of different parts, put them together to make one like machine. So I've put all the parts together into an assembly. So you can see this is 3 of the parts for the claw. Then I also have my arm body. So in addition to the parts, I need to put in fasteners. So I downloaded CAD off of McMaster-Carr, which is the company where I'm ordering my screws from. And they have it ready-made, you design it, and you put it into your assembly. After that, I set it up to 3D print it. So let me share that. This is the 3D printing software. So you can see the green stuff around the orange. The orange is my part, and the green stuff is all the supports. So if there's overhanging pieces, because this claw is a pretty complex geometry, there are some overhanging pieces. So I have the green supports, which will then be removed from the part after I'm done printing, and that helps it support anything that's hanging without anything below it. So I printed my part, I've got them all physically now, and I put them together, and I can make the machine. So you can see here, I can pick up things with my claw, like a screwdriver or like this 3D printed ball, and then I can sort them into containers, which was the goal of this thing. So you guys know with COVID, we've been doing classes remotely. We've been doing our design teams remotely, but we've managed to make it work. So something that I'm enjoying is I grew up in the countryside between Algonquin Park and Ottawa. So I've actually been living at home. You can see if I step outside here, this is my backyard. This is the river, the Madawaska River where I grew up. And I get to be home with my family and still doing all my classes online. And you might think, how do you make friends in online university? And actually, joining the robotics team is a really great way to do that. You get to meet people from all across engineering, but also all across Ryerson. We have students from every engineering program, but also almost every degree. We have art students, film students, professional communication students, business students, architecture students, you name it, they're probably on our team. We have about 130 students on our team. And so if you can hear the scratching, that's actually my puppy here, Rufus, sitting beside me while I do this. And I mentioned before, I'm an outreach lead on the team. So that's an opportunity to express your artistic side. We do coding workshops, computer-aided design workshops, and we also do like outreach presentations to elementary schools, high schools, and you get to communicate some of the amazing robotics work we're doing on the team. SolidWorks is not the only CAD software you can use. You can also use Fusion 360 or Onshape if you want to get started. There's some free platforms like that. If you want to hear more about some of the technical opportunities at Ryerson or some of the professional people working at the intersections of art and design, we're actually co-hosting an open house on Monday with the Design Fabrication Zone. The Design Fabrication Zone is a startup incubator at Ryerson, and they have a lot of really cool companies working on like robotic delivery systems. We have people making fashion out of like biomaterials, 3D printing costumes, all kinds of stuff. There's a really cool like hearing aid company that they're working on accessible devices for older people. So if you're interested in that, you don't have to be a student to attend, and you can see the sign up link on our Instagram. Now I'm going to throw it over to Trevor, and he's going to talk a little bit about the mechanical team because he's also a
Thank you, Vanessa. I can't wait to see that claw in person one day. Yeah, so my name's Trevor. I'm one of the mechanical leads on R3. Currently, I'm in my 4th year of school as a mechanical engineer. And right now, I'm on my co-op term actually at a transformer manufacturing company. One cool thing about this company is that they're flexible manufacturing, which means they can make many different parts of many different sizes versus just one constant thing that's always being outputted. These transformer cores can range from a fraction of a pound, which is very small, about this big, to over 20 tons, which is 40,000 pounds. Some things that I do there as a process engineering intern is work on the future state of the plant. So when a new machine comes in, I have to figure out where it can go, working with other departments to see if this spot's okay or that spot would cause any issues or anything like that. Another thing I do is assist in running projects. So when a new machine comes or a piece of equipment comes, it needs to be installed. So I work with the contractors that come in and help them whatever they need, possibly with maintenance, like the maintenance department, to make sure they have what they need to do their job and make sure things are running smoothly. So a bit about R3, some things I love is the family atmosphere. Like I'm sure Gabe and Vanessa mentioned, that we're all here to help each other. We're all here because we want to be. No one's forced to stay. So the work just gets done. It comes out quick, and everyone's just super involved with doing things. Another very important thing about being on any extracurricular team is the skills that you learn. You do learn a lot of skills in class, but you really get to solidify these skills in a team environment. Some of these skills could be teamwork, working with other people to get a common goal accomplished. Communication skills, that's very important. If you can't communicate your thoughts or your designs, it's almost impossible to happen. So you can really solidify your communication skills. Also, your technical skills you can hone in on. So 3D CAD skills, like Vanessa showed in SolidWorks, and I'll give you a little quick SolidWorks introduction as well. Along with like stress analysis, seeing if the part you designed will hold up to the stresses you're going to put on it, the forces you'll put on it, and the design process. So how you design things from start to bottom, or start to finish. So I will start off with showing you a bit of 3D printing. So over here is my 3D printer. Right now I'm actually printing these surgical mask clips for the mask that we have to wear. It just goes around your neck, and you can hook the loop on here instead of over your ear, because at work it started to hurt. So yeah, it's printing right now. The way 3D printer works, for anyone that might not know, or if you haven't seen one before, you have filament at the top, which is a spool of plastic, and then it comes down here into this part, which is called the extruder, which pushes the filament through a tube that reaches here, and then here there's a very hot piece. Oh, my finger's very bright. In here there's a hot piece which heats up the plastic and melts it, and then it pushes through a small nozzle onto the build plate and it prints your stuff. So on my printer I actually installed a, I'm going to share my screen in 1 second. There we go. Reload. Can everyone see this? I see Vanessa, so okay, awesome. So here is this is called Octoprint, and I can watch my print happening from anywhere in my house, just to make sure it's all going well and nothing is getting messed up. So yeah, that's a bit about 3D printing. Oh, in order to start 3D printing, you have to slice your part. So to slice your part, you use a software called Cura, and I will share that as well. A quick screen share. Right, so Vanessa used Prusa Slicer, I believe. Another one is called Cura, which is this here. And what you do, you put your part in, and you hit this button. Let me move something. You hit this button called Slice, and it slices into a bunch of layers, because a 3D printer only prints one layer at a time. Slices into a bunch of layers and configures how your 3D printer has to move. So you can see all the small little filament places where it drops the filament onto the build plate. Yeah, so that's that, a bit about 3D printing. I will do a very quick SolidWorks introduction as well. Let's share SolidWorks. Does this look okay? Cool, so here I have a skateboard which I downloaded offline or online from a website called GrabCAD. They have many different models that anyone can upload. It's kind of like, let's say Facebook, that anyone can upload stuff and you can download it and work with it. So I decided to download this skateboard, but there's a couple things I wanted to change. I actually changed the motor on this, and these motors here are the ones that we use on the rover, so I know they'll work well. It's called the Neo, Rev Neo. And one other thing I want to change is the wheels. So I'm going to open the wheel part and add some treads to it, because if I were to use this skateboard in wet weather, I think it would be a little bit slippery because the wheels have no grooves in it. So in order to fix that, I will cut some grooves in it. Let's do a quick sketch. So I'm making a line so I can draw up here. Let's make some grooves. Add some dimensions. Let's call this 4 millimeters. This as well. And have it 3 millimeters deep. I think that looks good. I'll close it off just so I can cut it out. And this is just a very quick sketch. I would make it a bit more proper if we were to if I had a bit more time, but for presentation's sake, let's do it quickly. All right, so I got one notch. Let's make that go all the way around. So it's a circular pattern in this direction using these features, 30 degrees apart. And I would like 12 of them to go all the way around, and there we go. So now that I have notches in the wheel, I can save it, Control S, and go back to my skateboard, which should have the updates there. Awesome. So now I can ride this in the rain. Should be fine. Cool. So yeah, that was just a quick intro to SolidWorks. I just wanted to show you this because it's incredibly powerful what you can do with this software. Basically, from what I can tell, almost everything is made on CAD before it's put into real life, because you can kind of see where there might be any issues. Like, let's say if I made these wheels bigger, it might hit on this top board. It'd be harder to tell if you didn't have it in CAD and just kind of imagined it. So that's just one example of many possible things. But yeah, I don't want to take up too much of your time. I hope you found this interesting. And if you have any questions, like Vanessa said, we can hopefully answer them in the Q&A afterwards. I'm going to pass the spotlight on to our Chief Operating Officer, Reem.
Hi everyone, I'm Reem. I'm currently studying business technology management. I'm actually on my co-op work term as a business operations analyst at Stack FinTech and Credit Sesame. During high school, I competed in FIRST Robotics, so I really enjoy that I can continue to do robotics in university. During first year, I joined R3's mechanical team to compete in VEX Robotics, where we were able to compete internationally in Louisville, Kentucky. Currently, I am the Chief Operating Officer for R3, so I mainly manage communications, internal and external to the team, whether that's with recruits, any email inquiries, or with our sponsors. We're actually sponsored by a lot of amazing companies, so it's great to work with them and have that connection with industry leaders in technology. So some of our sponsors include NVIDIA, SolidWorks, NeuronicWorks, Viking Engineering, Protocase, and of course, Ryerson University. We also do partnerships with really cool companies like FIRST Robotics and Trexo Robotics. So I really love being part of the team. R3 is really accepting and welcoming. As Vanessa mentioned, we have a lot of people from many different disciplines. As you can see, I'm a non-engineering student. I really love working with such a diverse and cohesive environment. And through R3, I get to help work on our awesome rover Navi. And I get to learn a lot about business operations. It's really never a dull moment at R3. So as you can see, I'm casually chilling with our rover Navi, the real star of the show. And Navi's just been my roommate during COVID, living in my garage, rent-free. Anyways, it's time to show off some cool features on our rover. To start off, I'm just gonna relocate a bit. Let's angle this downwards. Yeah, so to start off, here's the chassis that Vanessa was talking about. As mentioned earlier, it's 3D printed white PET G. So it's a great way to work in a COVID-friendly manner. It reduces the weight of our rover, and it keeps Navi nice and breezy. We don't want to be able to fry an egg on Navi during competitions in the Utah desert, so this works really, really well. Moving on, here's our suspension system right over here. Navi's really the GOAT, so we built her like one. We utilize a double lambda Rocky Boger suspension system, so we can really climb and get through any terrain, anywhere from snowbanks, piles of sand, and steep slopes. And I can just do a little demo of our wheels and suspension over here. So we can really get in through any terrain. Yeah, and then I'm just gonna move onwards. So we have other cool features on our rovers. So as you can see here, we have airless tires. They're made from 3D printed PETG hubs, which is right here. Oops. Yeah, you can see our hubs right over here. And we have casted polyurethane treads for flexibility, shock absorption, and traction. Just gonna move right over here. So we also have our top arm right over here, which is really great for precision tasks. So we can actually flip switches, type on a keyboard, and do all those tasks for our competition. And on board, we do have a science system for competition, which conducts onboard analysis of soil samples to determine any signs of life. And yeah, that's a little bit about me, Navi, and R3. Thanks for having us, and don't forget to follow us on social media.
That is awesome. I was muted. I love the airless tires. That fascinated me. So we do have some questions that came up. So I'm gonna, if before want to jump back on, we'll try to go through them a little bit quick so we can kind of go into the next section as well. But a lot of people super fascinated by this team. So I'll just go kind of question. I know that we kind of answered some of them, but I'll just make sure that I get through them all. So question one, and I think we just found out, but do you have to be a part of mechanical engineering to join the robotics team?
You don't have to be part of any engineering to join the robotics team, actually.
Cool.
So we take students from almost every faculty. We have art students, business students, and engineering students. So that answers that, yeah.
Great. So we have about 7 questions. So we'll, the other question is, the rover looks similar to NASA's. Does it have the same design and hardware?
Well, thank you for the compliment.
Yeah.
It's not exactly the same. We wish we had a NASA budget, but not quite. But we do look at what NASA does, but we also look at what other universities do, and we come up with our own creative ideas. So it's not the same design, but we definitely do keep an eye on NASA and on the Canadian Space Agency and the European Space Agency, seeing what's new in the field and what we could potentially do on our rover.
They do share a little bit of technology, so more on the mechanical side than the control side of things, unfortunately. For example, the upper part of the suspension, I don't know if Reem showed it, the like rocker part. Perseverance has something similar to that, but theirs is mounted on the bottom, actually.
And that suspension is a double lambda rocker bogie suspension.
Yeah.
Yeah.
To be
Quite a
specific.
mouthful,
I was going to say, we all know what that is. Cool. So, and I think the question might have moved, but where do you gain the knowledge to build such an advanced robot? And do you need any previous experience or knowledge to be a part of the team? So we kind of combined it 2 questions.
Yeah, so it's different for every person. That's actually why we started the Media and Outreach team. I founded it last year, and we've always done a lot of internal mentorship. Mentorship is one of the core values on our team. So you can come to the team without any experience as long as you're excited to learn and enthusiastic. And we do seminars and we do teaching modules where we give you assignments and we walk you through them and we teach you the skills you need. And so now we're trying to expand that to the wider community. We're hosting Python workshops for all of Ryerson, and we're teaching CAD. And if you keep an eye on our YouTube channel, we should have some CAD tutorials coming up soon. So things like that. We already have a Python tutorial on our YouTube channel if you wanted to work on your and then you also take what you're learning in class and you apply it on the team. That's something I love because class can get really theoretical. But at the end of the day, I can go to the robotics team and be like, okay, I've learned these new concepts. Let me actually make something with them.
And then the question came up, can you join more than one subgroup?
Yeah, so Vanessa is actually a prime example of that. Vanessa, do you want to talk about your time on mechanical and outreach team?
Yeah, so I'm both a lead on the mechanical team, leading our chassis team, and I also lead our media and outreach team. So I go to both meetings and I get to do a lot of crossovers. So from the mechanical side, I can teach some really cool mechanical skills through our outreach. And from the outreach side, I really work on my communication skills, which just makes me a stronger leader overall. So they feed each other in both ways.
Cool. And I think one of the big things that I recommend to students is time management. So you can join multiple things, but just make sure that you're always a student first, and just make sure that you're managing your time. So maybe in first year, you don't join 5 teams at once, you go for one and then start from there. So awesome.
To add to that, that's also something that we are very big on too. We don't want our students to burn out. We want you to be around for all 5 years, or all 4 years. Sorry, my case is 5 years. So we really try and encourage students to focus heavily on school, because it is very important. You need to get your degree at the end of the day, right?
And with that, because we're all students, we often take midterm weeks off. We won't have any meetings. We'll say we'll block out that time. Or for instance, my chassis team's not meeting during April. I'm like, study for your exams. You don't have to worry about robotics. We'll come back in May.
Cool. And then we can go on to, and I think it was touched on, so I think it's a simple yes, but is the competition you compete in similar to FIRST Robotics competitions?
Yeah.
But
so a lot of us do come from FIRST Robotics. Like, I have a FIRST background myself, but it is very similar. It kind of similar. Like, it builds off of the same knowledge base, but much more advanced.
And then I think we touched on this a bit too, but just to confirm, is the team open to all, or is there a selective process?
It's open to all, for the
Cool.
most part. Yeah, like
no one's turned away.
Yeah,
as long
no
as you come to the meetings, you hand in your work. As long as we're seeing you, we set deadlines for application projects. As long as we get it from you, you're welcome on the team.
There needs to be a clear communication. Sorry, if if you want to join, there, like they said, you can join as long as you're constantly involved. Like, if you have to take a week off, 2 weeks off, as long as we know, that's all that matters.
Yeah.
If you just disappear, we kind of assume, okay, you're no longer interested. But yeah.
Cool. I think we touched on this as well, but how does R3 get money to make projects?
Sponsorships.
Mainly from the school and through sponsorships. Yeah.
Cool. And then here's one. Ever thought about adding a drone in the rover?
That's an interesting question. So something we looked at, I think it was 2 years ago or last year. There's another competition similar to the RoboSub, which is actually like a boat, a drone, and a sub as well, and they all kind of have to go together. We didn't do that competition just because it was like a lot of overhead, and it would be like we would need basically our whole team as it is now to be focused only on that project to do it well. So maybe it's something for the team in the future, but I don't know about right now. But we've considered it, yeah.
Cool. You need to get more funding. No. Awesome. So that's all the questions that have popped up. So that was awesome. Thank you so much for joining us today. And joining a team is a great way to get involved and be part of the community and learn different things. So thank you so much for joining us today.